So we were saying that we developed together a relation between velocity and position. So we have until now v as a function of s. And since we want to relate to time, we should use the differential equation, which involves velocity, position, and time. And this relation is v equals to ds by dt. Okay? So now, if I put v equals to ds by dt.
Example 12.4. Solution.
Equals to, guys, please, can you mute your microphones if you are not asking questions? Equals to this expression, okay? Which is the function we have derived together, which is 2 times radical of s squared minus 0.01. Okay, now because velocity is function of s, when I do separation of variables, I will take it to the side of s, and I will take dt to the other side. Okay, and then my relation becomes ds over the function equals to dt. So let me write it here. So after doing separation of variables, I get ds over the velocity expressed function of s. So over 2 radical s squared minus 0.001 equals to dt. Okay, equals to dt. Now, after I did separation of the two variables, time and position, I can integrate both sides. Okay, so I can say that integral from s of c, which is the beginning point, which is equal to 0.1 meters. Since my interest here is to get the time when reaching B, I can directly, and this is the final step of my problem, I don't need to get as function of time, okay? Because this is the final step in my problem. So since they didn't ask for the function as function of t, no need to find it. I can directly use my calculator and say, I will calculate this integral between point C and point B. So I put this equation on my calculator. It will give me directly the value of the integral from 0.1 to 0.2 of this function. And this from the other side will give me integral between TC and TB. Since the origin of time is selected at point C, TC is 0, and TB is what I want to find. So when I integrate dt, since the function here is 1, integral dt is t, so this will give me TB. And then I can solve for the time needed to reach point B. Okay? Any question on this?
Professor, I have a question.
Yes.
Now we derived from the last exercise and v squared equal to 4s squared minus 0.04.
Okay,
right?
my radical 4 is what?
I know, بس أنا على أساس أخذنا إنه البوزيتيف مش النيجاتيف مثلا استعملناها بقلب ال differential
here
equation
you are
of
moving,
S
yes,
T.
okay, exactly, because you are moving downward. So V is downward, and your coordinate is positive down. So let me go back to the figure. Look, 1 second. This is your figure. How is your positive direction of S, coordinate S? It's down. And when you move from C to B, you are starting from rest, okay? So as you are moving down, since you are accelerating, they told you under the effect of the magnetic field, you have an acceleration down, a downward acceleration, A equal to 4S. So in this problem, S is positive down, A is positive, and since I'm moving downward, okay, my velocity is positive because it's in the positive direction. So since here both A and V are positive, I have acceleration. So V will increase from 0 to, as you move down, the velocity will increase. So you are sure here that the velocity is not negative, it's positive. So you will select the positive solution.
Okay, thank you.
First, anyway, I will explain the situation. So, I was online the other day watching or looking for phrases on this.
Any
website
other question? Can you please mute your microphones if you are not asking question, please? Any other question on this problem? Okay. So let us continue. We'll practice now with this problem on the difference between average velocity and speed during motion. Okay, so in this problem, I have a particle that is moving along a horizontal path with a velocity v function of time equals to 3t squared minus 16 meters per second. If it's initially located at the origin O, determines the distance traveled in 3.5 seconds and the particle's average velocity and speed during the time interval. So in this problem, I have v function of time. V function of time is given, and I know the initial position of my particle. My particle starts motion from the origin of my frame. Now, the question is to determine the distance traveled by the particle in 3.5 seconds, and then to calculate during this interval the average velocity and the average speed. Whenever you have such problems and they ask for a distance, you cannot calculate the distance before knowing the path of motion, because if you go straight forward, you can say that distance is the absolute value of displacement. But if you change sense during motion, calculating just the displacement delta S is not enough, because I will just have an idea about the initial and final position, but not the trajectory. Okay? If I give you v function of time, how you can determine the trajectory? Do you have an idea?
V equals ds over dt.
Yeah, okay. It's true. V is equal to ds over dt. Okay. So if I use this relation, I can get as function of time. Exactly. So I can plot, if you want, how s is varying with time. This is one strategy. Okay. I can also just to know if I'm moving to the right or to the left and what are the extremities of my motion. I can say that if I find at which positions v equal to 0 and I study the sign of velocity, I can know the trajectory of motion, how it's going, if it's going to the right or to the left. So one good thing to do whenever I want to find the total distance traveled is to study the sign of v. And if you want, this corresponds to solving v equals 0, and then determine between the solutions if I have a positive or negative sign. So in order here to study the sign of v, v is a second degree function of time. Okay, so if you want to solve for the sign, so you can do this. You can say first, let me solve for the times corresponding to a velocity of 0. If the velocity is equal to 0, this means that 3t squared minus 60 is 0. And if I take into factor 3t, then this is equivalent to 3t times t minus 2 equals to 0. Okay. Now, next step will be to say that the possible solutions for v equals 0 are t equals 0 and t equals to 2 seconds. Okay. Now, the first solution corresponds to the start of motion. So since this will tell me that I'm starting from rest, so this is the initial condition, and it will become 0 again at 2 seconds. Since I have a second degree function, you know that for a second degree function, when you find the two solutions, between the two solutions, the sign of the function is opposite to the coefficient of t square. Here, the coefficient of t square is positive, it's +3. So this means that I can draw now the table of sign for velocity. So I can plot time t, velocity v. I have the boundary, the values of t for which v is 0 are 0 and 2. And between 0 and 2, the sign of, so v will have a value of 0 here and 0 here. Now, from second degree properties, we know that between the solutions, the sign of velocity will be opposite to the sign of the coefficient of t square between 0 and 2. And in the other intervals, it will be of opposite sign. So it will be of same sign, sorry, it will be positive. So now, from this simplified analysis, I can say that at t equals 0, I was at O. Between 0 and 2 seconds, my velocity is negative. This means that I'm moving backward. So if I take the positive direction to the right, then between 0 and 2 seconds, I am moving to the left. And my velocity will reach 0 again at t equal to 2 seconds. Because now the velocity will reach 0 and will switch sign from minus to plus. This means now that I change sense of motion. And in the remaining time, my interest is between 2 and 3.5 seconds. Between 2 and 3.5 seconds, it will move in the positive direction. So now I have an idea about the trajectory of motion. Now, to complete the picture, to have a complete picture, I need to find what is S when I reach at t equal 2 seconds, and what is the position S at 3.5 seconds. In this way, I will know all extremities of my motion, and I will be able to calculate the distance traveled. Okay? So to do this, I start by saying, as your friend said, I have v function of time, and I want to get the position, so I should use v equals to ds over dt. And now I replace v by its expression, so this is equal to 3t squared minus 60. To get s, then I should do integration. I can do separation of variables. I will take dt to the other side. So I will get that ds is equal to 3t squared minus 60 dt. And now I will integrate between the desired time. So as we said, the first step, I am interested into getting what is the position S at 2 seconds. If you want, let us find the general equation, and then we replace t by 2 seconds and t by 3 seconds. So to get the general equation, I will integrate between the initial position, which is at the origin. So integral between 0 and any s. And from the other side, I will integrate between the initial time, which is also 0, and time t. Okay, integrate between 0 and t. We know that integral ds is s. So the integration of the first side will give me s equals to If I integrate between 0 and t, the other side, it's a simple function to integrate. The integral of 3t squared is t cubed. And the integral of minus 6t is 3t squared. So now I have the general expression of s function of time. So I can say, then let me determine the interesting position. I know that initially I was here, this is the boundary condition I have at t equals 0, s equals 0. I need to find what is the position I reach for t equal 2 seconds. So if you plot to get s at 2 seconds, you just have to plot instead of t, you put 2. So you get 2 cubed, which is 8, minus 3 times 4. So you get minus 4. Then you can say that after 2 seconds, I am at 4 meters to the left of O. I have a negative value of S. And this will confirm for you that between 0 and 2 seconds, I'm moving backward. I have a negative velocity. Okay. Now, in the second step, I still need to find what is the final position at 3.5 seconds. So also all I have to do is to plug instead of t in my equation, I put t equals to 3.5. And if I solve, I will get that the position S will become equal to 6.125 meters. So until now, doing this analysis, I was able to plot this graph. This graph will not be provided for me. I should plot it. Okay? Any question on how we found the extreme times and the values of S?
Yes, Dr. One
Yes.
question.
Yes.
When we will plug 3.5 seconds,
Yeah.
will we get 6.125 or we'll get 10.125? Because there is the
We will get 6.125 because S is measured from O. Okay? So S is always measured from the origin of your frame. When you say S, this is a coordinate. It has a reference. What is the reference of S? It's point O. So when you plug in your relation, you will not get the distance traveled from 2 to 3.5. No. You will get the position relative to O. Okay? Because you are getting S of the point, and S of the point is measured with respect to which point? With respect to the origin. So what you will get when you plug T 3.5, you will get the coordinate of the final point, and the origin of this coordinate is O, so you will just get 6.125. Now, if you want to calculate after what is the distance moved from 2 to 3.5, then you should add to 6.1254, and this distance will be 10.125. Okay?
So the total distance will be 14.
So the total distance will be 14.125 because I have two phases. I first should consider the backward motion, and since distance is always a positive value, I will take the absolute value of displacement. So in phase 1 I moved 4 meters, and in phase 2 I moved 10.125. So the total distance traveled will be 4 plus 10.125, and it will be equal to 14.125. Okay, so this is how I can find the total distance. While if I calculate the displacement, what will be the value of the displacement here? Displacement delta.
6.125.
Exactly. If I just want to know the displacement, if I name my points, so let's say if this is point 1, this is point 2, and this is point 3, delta S between 0 and 3.5 will not take into consideration point 2 It will just take into consideration the position at s equals 0 and the position at s equals 3.5. So the total displacement is s of 3 minus s of 0.1, which is equal to 6.125. And this is an example where you can see that the displacement will not give you an idea about the total path of motion. So if you calculate now the average velocity will just take into consideration the displacement. So V average will be delta S over delta T. So it will just be 6.125 over 3.5. While what will give you a better idea about your motion will be what? Will be the average speed. Because when you calculate the average speed of motion, what will be the formula you will use? For the speed, you will take into consideration the total distance traveled. So if you want to calculate the average speed in this problem between 0 and 3.5 seconds, then you will take the total distance traveled, which is 14.125 over 3.5, which is much larger than the average velocity. Okay. Any question on this? If anything is not clear, I can repeat. Please, if you have questions on this problem, let me know.
Thank you, Professor.
Okay,
Professor,
well,
I have a question.
yes, tell me.
So the average velocity, we take the displacement over time, and the average speed, we take the distance over time?
Exactly. We defined this in the course
Okay.
material, yes.
Okay, thank you.
Okay.
Professor,
Yes.
do you have office hours?
Yes, anytime after the course. Yani, if you want now to ask your questions, you can.
Oh, okay, لا, بس I'm asking in general.
Yeah, we can determine an appointment. So, and you can ask your questions, of course.
Thank you.
Welcome. Any other question?
Thank you, Professor.
Welcome. See you next time.
Thank you, Professor. Have a good day.
You too. Bye.
Bye.
Bye.